So good evening everyone. So today I'll be introducing what is conic sections and specifically the circle, which is one of the fundamental shapes in this topic. So as shown in the image, conic sections are the different shapes formed when a plane intersects a double knot cone, which is these shapes are including the circle, ellipse, parabola, and hyperbola. So each of these curves has unique properties and plays a significant role in mathematics and real-world applications. So today, I will start by discussing the meaning of conic sections and then go into detail about the circles. So let's begin. Let's proceed to the next slide. So now that we know that what conic sections are, let's look at how they are formed. So a conic section is a curve created when a plane intersects a double right circular cone, right? So the cone has a vertex which divides it into two parts called the upper knot and the lower knot. So as shown in the figure P, different angles of intersections create different conic shapes. So this is the foundation of conic sections, which we will explore further. So now we have different conic sections were formed based on how a plane intersects a double knot cone. So the shape of the conic section depends on the position of the angle of intersection at which the plane cuts through the cone, right? So if the plane cuts parallel to the base, a circle is formed, okay? If the plane cuts parallel to the base. So if the plane cuts at an angle but does not pass through the base, it is an ellipse. It created an ellipse shapes. And if the plane is parallel to the cone's slant, it forms a parabola. And lastly, if the plane intersects both naps, it results a hyperbola. So these classifications helps us to understand the different curves found in nature and mathematics. So now let's proceed to the next slide. So we understand how conic sections are formed. So let's focus on one specific shape, which is the circle. So the slide introduces the circle in its standard form and how it relates to conic sections. So a circle is a set of points in a plane that are all at a fixed distance, called the radius, from a central or point from any central point known as the center. So the diameter is twice the radius and is the longest possible chord of the circle. So for example, drawing a perfect circle on a piece of paper using a compass, the tip of the compass stays at the center, right? While the pencil moves at a constant distance around it, and it is fixed, not changing. Okay, so this is exactly how a circle is defined in mathematics. So in terms of conic sections, a circle is formed when a plane intersects a cone perpendicular to its axis. This means the plane cuts straight across the cone's top, creating a perfectly round shape. Okay, so now let's proceed to the next slide. Okay, now that we have defined what a circle is, so let's see how we can represent it in a coordinate plane. So in a rectangular coordinate plane, we can define a circle mathematically based on its center and radius. So the center of the circle is represented by the point HK. The radius R is fixed distance from the center to any point X, Y on the circle. So this setup is crucial because, or important, this is very important because it allows us to derive the standard equation of a circle, which we will explore next. By knowing the center and the radius, we can describe any circle algebraically and graph it accurately on a coordinate plane. Okay? Now we understand how a circle is represented in a coordinate plane. Let's see how we derive its equation using the distance formula. So the equation of a circle is based on the distance formula, so which calculates the distance between any point x, y on the circle and its center hk. Since the distance from the center to any point on the circle is always the radius, the small r, we set up the equation, the square root of the quantity of x minus h squared plus the quantity of y minus k squared is equal to the distance, or dr. Okay, so the radius. By squaring both sides, we eliminate the square root and obtain the standard form of a circle's equations, which is the quantity of x minus h squared plus the quantity of y minus k squared is equal to r squared. So this equation makes it easy to identify the center, hk, and the radius r of the circle. So for example, in the equation, the quantity of x minus 2 squared plus the quantity of y plus 5 squared is equal to 16 represents a circle with the center at positive 2, negative 5. Since subtracting a negative number is the same as adding, okay? So our radius here is equal to 4, and because r squared is equal to 16, so r is equal to square root of 16 is equal to 4. So r squared, square root of r squared is equal to r itself. So now this equation helps us quickly determine the properties of a circle, making it useful in graphing and problem solving. So let's proceed to the... So now, in this slide, it explains how to determine the center and the radius of a circle from its equation in standard form, which is the quantity of x minus h squared plus the quantity of y minus k squared is equal to r squared, where h and k there is the center of our circle, and the r is the radius of our circle, given by r is equal to the square root of r squared. So now let's break down to the table. Let's proceed to the table. So we have the first equation there, which is the quantity of x minus 3 squared plus y minus 4 squared is equal to 25. And it indicates there that the center is positive 3 and positive 4. 3, 4. And our radius is equal to 5. Or the square root of 25 is 5. So let me explain first. How does the center is equal to 3, 4? So first thing is, to find the center, our hk there, you correctly set h squared terms inner expressions equal to 0. So first expression is x minus 3 there, right? Or we're just simply applying the method of setting each binomial equal to 0. So first expression is x minus 3. So how are we going to find our center or the hk? So first thing is to set our h of binomial. So first expression is the x minus 3 equal to 0. So by setting that equal to 0, x minus 3, we will get positive 3, where we are applying first the addition property of equality, adding 3 from the both sides, positive 3, and that will get, by isolating the x, we apply that method, and then we will get the value of our x, for our h first, which is positive 3. And then next expression is the y minus 4. So we are going to, as what I've said, setting each the binomial there equal to 0, or setting each the squared terms there in an expression equal to 0, which is the y, one of it is y minus 4. So in order for us to get our k, one of our center, which we get already the first, which is the 3, positive 3, and then for the y minus 4 equal to 0, we will get positive 4. Isolating the y, which we are going to apply the addition property of equality, adding positive 4 from the both sides, and that will get y is equal to positive 4. So that's why we get the center 3, 4. And then for the radius, in the given equations, we have equal to 25. Remember, r is equal to the square root of r squared. So r is equal to the square root of 25 is equal to square root of 25 is 5. So that's why we have a radius 5. And then to the second equation, same process of how we are going to get the center. The second equation, quantity of x minus 1 squared plus y, the quantity of y plus 2 squared is equal to 7, which the center there is positive 1, negative 2. Since y plus 2 is rewritten as also in a standard form of a circle, which is y minus k. So rewritten that as y minus the quantity of negative 2. So which we have the negative 2k in our k. And then our ranges there is the square root of 7. And then the third equation is the quantity of x plus 4 squared plus the quantity of y minus 3 squared is equal to 1. And the center is negative 4, 3. And since x plus 4 is rewritten as x minus in the standard form, which is x minus h, which rewritten that x minus the quantity of negative 4. That's why we have our x term, which is negative 4, or h term. So our radius there is 1, which the square root of 1 is 1. 1 times 1 is 1. Okay, so the last equation is x squared plus the quantity of y plus 6 squared is equal to 8. So our center there is 0, negative 6. Since x squared means x minus 0. Okay, then the radius is 2 square root of 2. Since the square root of square root of 8 is 4 times 2, and then the square root of 4 is 2. That's why we get 2 square root of 2. Then let's proceed to the next slide. See, do an example. First example. So we are going to graph the circle given by the equation, which is the quantity of x minus 2 squared plus the quantity of y plus 5 squared is equal to 16. So first thing to do is we need to identify the center and the radius of that certain equation. So the standard form of a circle's equation is the quantity of x minus h squared plus the quantity of y minus k squared is equal to r. So comparing with our given equation, we will have our h is equal to 2 and our k is equal to negative 5. So the center is 2, negative 5. And our radius, where the square root of 16 is equal to 4. And then step 2 is by determine the quadrant, which the center of our circle is positive 2 and negative 5, which our x-coordinate is positive 2, which is positive, meaning it is to the right of the y-axis. And the y-coordinate is negative 5, so it is negative, meaning it is below the x-axis. Since the center is in the positive x region and negative y region, it is located in the fourth quadrant. So next is we are going to plot the circle. So from that image it is already plotted, but we must explain how and why. So first thing to do is mark the center at 2, negative 5. So we are going to locate it in the fourth quadrant. So that's why it is located from the fourth quadrant in that picture. And then from the center, move 4 units each, from up to left and up to right and up and up to down. We are just going to move 4 units. That's why from up we are going to move 4 units, which we will get positive 2, negative 1. And down to, we are going to count 4 units, we will get positive 2, negative 9. And then left of that center, we are going to count 4 units, we will get negative 2, negative 5. And right of that center, from that center we are going to count from that center to the right, we will get positive 6 in 4 units, positive 6, negative 5. And after that, draw a smooth curve connecting these points to form a perfect circle. So in this report, we explored that circles as a fundamental part of conic sections, which we discussed their standard equation, geometric properties, and unique characteristic of it. So as a circle is defined by its center and radius, which are essential in plotting its graph accurately. And by identifying these two k components, we can easily visualize and understand the structure of a circle in the coordinate plane. And understanding its importance of the circles in the conic section, within the conic sections, it helps us in mastering their mathematical properties and applications. Their symmetry and simplicity make them a key concepts in geometry and algebra, reinforcing their significance in mathematical studies. And that's all. Thank you.